Hello and welcome. Today we're going to cover phono circuits used in audio amplifiers. I'm going to explain them and then typical types of faults. Now, to begin with, it's very important that we cover the manufacturing of vinyl records. So what you see here are the cutting lathe and what we refer to then as the metal stamper, and also a production press to produce literally hundreds of thousands of vinyl records, and we'll go into that in a little bit more detail now. So when we think about recording studios, they would commonly use the Neumann VMS 70, and the 70 comes from the 1970s, which when it was designed and manufactured. But the Neumann cutting lathe really would be seen as the ultimate when you are producing vinyl records, and there also is a VMS 60 which was then produced during the 1960s. Now, an audio engineer, an audio technician, would have both the experience and the expertise in order to operate the cutting lathe, but of course the audio then which would then be transferred through all the different signal quality levels for the production of the lacquer disc. And like a woodworking lathe, what you have here is a cutting tool which will then cut directly the groove into the lacquer disc. And you know that is really a process which has to be error free. So once the lathe has cut the disc, the next part is that the lacquer disc would then be washed and then inspected to ensure that there was no errors, because what we have here is really a continuous groove which is then cut. And what you'll see is that the indentations of the groove of course reflect directly the audio, and if there is a scratch on the lacquer disc or maybe any imperfections, then when we then produce what we call the metal stamper disc, and we'll talk about that in a moment, then you would have a flaw then in the manufacturing process. So very, very important that the lacquer disc is error free. And then the next part of the process then is to create what we call a stamper, and the stamper disc is used to produce the end product, which are vinyl records. Now, and I always love this way humans solve problems or solve challenges, and it's sort of when you think back to when this technology was sort of developed, it is impressive. So what happens here is once they have the master disc or the master lacquer disc, what happens is that disc is then sprayed with a silver coating. All right, so silver is sprayed directly onto the lacquer disc, and then what happens then is that the disc is then coated with a hard nickel. So it goes into what we call a plating bath, and this is an electroplating bath, and what will be transferred is nickel. Now, nickel is a very, very hard metal, and because of the silver coating, the nickel adheres directly then onto the silver coating then. And as you can see here, I'm mentioning that it's an electroplating process, and then that then produces the stamper disc. Now, once the nickel coated stroke silver layer is removed from the lacquer disc, what then happens is it is then first polished, then it's then sanded, and then what they then do is they'll then cut the lacquer disc then to fit directly, and you can see here the pressing machine. Now, to give you some sort of idea of the longevity of a metal stamper disc, commonly a metal stamper disc will produce 100,000 vinyl records, and then after that then the disc of course then would be replaced, and then another metal stamper disc would be used. Now, when the metal stamper disc is produced, of course, instead of the track being indented as it is with a lacquer disc, of course it's now raised, so it's inverse because it's been peeled away then from the lacquer disc. So when you look at the production of the record, what happens is that the press itself has an overall pressure of 2,000 pounds per square inch. So that is a very, very high amount of pressure. And then what you'll have here is a steam heated process which will and these are like pellets that drop down, so it's polyvinyl chloride. polyvinyl chloride pellets, which are then melted, and then they then drop down and they produce what we call a biscuit. And if you sort of look at them, they're more or less sort of like a burger bap, you know, before it's produced. And then as it's then dropped directly onto the press, the label is also positioned for the vinyl record, and then it is then pressed down using the 2000 psi, and then that produces the vinyl record then. And as I said earlier, when we think about the production of vinyl records, the center hole where it positions onto the record player or onto the actual record deck, the centering hole is drilled secondary. All right, so the hole is not present during the initial pressing of the vinyl record. It's something that is done at a later date. So just to recap, we produce first of all the lacquer disc using, in this case, the Newman VMS 70 cutting lathe, and then from there we spray the lacquer disc with silver, and then from there what we then do is we then coat the silver sprayed lacquer disc directly with an electrocoating process to produce a hard nickel coating on there, and then it's then peeled away from the master disc, and then once it's been polished and then sanded, it's then cut, so there'll be excess around the rim, so it's then just cut to fit the vinyl press, and then we heat up polyvinyl chloride pellets, which are dropped down onto the press itself, and then we produce a biscuit, and then from there with the label we produce the vinyl record. So you can see that there. Now when we look at the different types of record players, or shall we use also the word turntable, what we show here are solid state devices. Okay, so when I refer to solid state, what I'm referring to here are some of these record players have an inbuilt amplifier, and what they are using are transistors. So there are no thermionic valves in this example that I'm showing here, which is on the left hand side. Now very early mono record players had germanium output transistors before the silicon type transistors were introduced, and you can see during the development of different type technologies in the early 60s you had these mono record players which were portable. So you know, if you were going around to a friend's house, you know, you could just literally carry your mono record player, you know, around. You've got a box of singles or maybe LPs, and it has a self-contained mono amplifier, and then normally from the front you probably have just your volume and maybe your tone adjustment. And these were very popular, and you can still purchase them now, you know, from auction websites, and if you wish you can then refurbish them. And then as technology moved on, then you started to see really in the 1970s, you know, the development then of stereo record players, and it was not uncommon even for some of these to have an integral amplifier built in. But around this sort of era you also started to see the introduction then of separates, and the amplifier, you know, often these amplifiers had a selection also to run as mono or stereo, because some of the vinyl back then would have been recorded either stereo or the earlier ones then as mono. And then when we look at a modern type turntable, you know, here in terms of technology, the way in which the record player or high-end turntable operates significantly changes. So what I'm referring to here is in the early type ones from the 1960s, these types of record players not only had an inbuilt amplifier, but they also had what we call an auto changer. So you could stack up to 10 individual singles onto there, and then what you had is an arm which went across, which just held them horizontally and kept them compacted down, so it would then operate. And then as the record arm got to the end of the record, it would then move back, and then that would then trigger the mechanism then, and then what you would have is another single or 45 would then drop on, the arm would then move across and then play that one, and up to 10 of them. If you didn't want to operate the auto changer mechanism, you could actually remove it from the record player, and then you could then just play a single. But equally so, if you wanted to repeat, and again, there's no electronics involved here as such, it's just purely mechanical. If you then move the upper arm to the right hand side, literally what will happen is that the record arm will come to the end of the vinyl record, it can move back, and then it will repeat. So it will just keep on playing the vinyl record over and over then. And literally it's just like a mechanism where you just select which type of record you want to play. So it could be a 45, so that means a single. It could be a 33, which is a long player or LP. And on the earlier ones you also had 78 speed. But when we talk about 33, 45 and 78, we're simply talking about revolutions per minute. So how many rotations does the disc make within 1 minute? So 45 means 45 revolutions per minute. And very, very common. And then on the latter ones, which sort of like the 1970s, you had more technology coming in and more sophistication. So here, you know, they almost became pieces of furniture. So you can see that the wooden cases, maybe it was walnut that was used, and I would say also as well like a considerable purchase price for, you know, a household, and it would have pride and place then. And then on the new type turntables, what you started to see being introduced was more electronics. So you can sort of see just on the left hand side for the modern turntable that I'm showing here, what you are seeing is what we call a servo mechanism. So you have an optical encoder, and then on the platen, which is what the actual record sits on, and then it rotates, what you are measuring here are pulses which are generated via the optical encoder. So from an electronics point of view, we have what we term as closed loop. So it's just measuring the rotation, and then what it will then do, it will automatically increase or decrease the speed of the platen or the turntable to ensure that it's kept at the correct speed then. And then at the very, very high end, so we show an example here, you know, this is a high-end turntable which could retail for literally thousands of pounds, euros or dollars. Okay, and audiophile and people who have, you know, that kind of wealth would purchase these types of turntables, but fundamentally used to play vinyl, you know. So it could be entry level or it could be high end, just really depends on where you are. Now for the drive mechanism, it was very, very common to just have what we call an idler wheel. So as the mechanism engaged, it would then connect them with the underneath of the platen, and a bit like a potter's wheel, you know, in pottery, it would then rotate the platen. And then again, as technology moved forward, a lot of turntables, and even like today, they are belt driven. And when you look from the top of the record player or turntable, you have a rubber mat, which of course prevents or tries to reduce the chance of the vinyl record slipping. But if you remove it, normally there's a hole, and then you can then get access then to the belt. So if you needed to replace it, you can then put a new belt on, and then you hook it then around the drive motor. More commonly now, a lot of turntables are direct drive, so there isn't a belt or there isn't an idler wheel. They are mounted directly onto a motor, and the motor is providing the rotation. But in terms of the motors, this is another important point. Some of the very, very high-end turntables don't use metal bearings. Okay, they are using ceramic type bearings, because with any motor you will have noise which is generated. Alright, so I'm not really referring here to electrical noise. Yes, it can happen. It's more around mechanical noise, and we'll mention a little bit later why that is important and what amplifier manufacturers have done to sort of minimize the effects that sort of creates then. And then the other point about the rotational speed of the vinyl records, it has to be continuously and constant. You have something which we call wow and flutter. So that means where you have fluctuations in the speed of the platen as it rotates. So if it reduces slightly or it increases, you can have this wow and flutter effect. And this would be also the same, say, for compact tape players. Very, very common. And then you could do adjustment from that. So it's very, very important to ensure that you have this constant speed. And then in terms of weights for different types of vinyl records, so a 7-inch or 45 would be approximately 120 grams to 150 grams, and then a 12-inch record or an LP would be 180 grams. And I did grow up, of course, you know, from the early parts of vinyl, and for anyone who has, you know, extensive vinyl collections, or maybe is starting to get into vinyl for the first time, it's the thing that you have to avoid is heat, you know. And even back, you know, when I was growing up, you know, sometimes, you know, the vinyl records would sort of get left in the living room and the sunlight would come through, and then you can get the vinyl warping. And a little bit like, you know, a mini roller coaster, you could literally see the arm would be moving up and down because the record was then warped. Sometimes you would even buy a brand new record from the record store, and again, it could be slightly warped as well. And then the other thing that you need, of course, to avoid, and that's why they always have these paper or cardboard sleeving, is any scratches on there, because if the scratch is on there, it'll be picked up by the stylus within the record player, and then the excuse me, and then the other part then is the types of cleaning that you do. So, you know, normally it's a lint-free cloth, but I do remember way back in the 1970s, you know, people would sort of clean these things like with like a spray furniture polish. Again, you don't want to be doing that. So important thing with vinyl records is really sort of keep them out of the direct sunlight. You don't want any warping effect happening. And then also as well on your cleaning, and then also with regard to not scratching, you know, don't scratch the vinyl. Now the next part that we need to look at are the types of cartridges which are used, and many people who are buying amplifiers, or they're buying Phono Pre-Amplifier stroke equalizers, will select either a moving magnet or a moving coil type cartridge. So we're going to do some sort of clarification around that, and again you can see from the video the two types. So in today's world, the most common type that you will see is a moving magnet type, but there are Phono Pre-Amplifiers that you can buy, and you can select between moving magnet or moving coil cartridges. Some of the early record players also had as well moving magnet and moving coil inputs, so they either had separate connections, or you could select from the back of the amplifier and switch between the two. And we'll do the clarification on, you know, the different types. In the case of the moving magnet, what you have are a magnet which is attached directly to the stylus, and it operates like a cantilever, and it's very, very important on what we call the gram setting. So what you really want is when the record arm player arm comes across, you need to keep the gram pressure at the correct level. So what I'm saying here is, if the gram pressure is too light, what you could find is that the stylus then skates across the vinyl record. Very clearly, so what you want to avoid is excessive weight, so it's now pressing down too hard. And then on early record players, you know, they were kind of fixed. If you wanted to increase that, and you know, I grew up, you know, seeing this, sometimes people would put a small coin on the front head where the stylus is and just tape it on there, just to add extra gram weight. On more modern record players, you have a wide range of settings, and I'm showing this here in the video. So at the back you could set the pressure for the gram weight, and then you could also have as well an anti-skate adjustment as well. And instead of the arm moving across automatically or semi-automatically, electrically, you would be able to just raise it up yourself and then place it onto the vinyl record, or it may have some form of lifting mechanism which you can raise and then lower. And then in terms of the stylus, this is very, very common. So instead of it just being a single stylus where you then connected it into the cartridge, I'm showing here a stylus which is removed, and you can see that it says LP. and the diamond on there was slightly different. So as you flicked it across, because the grooves of course are going to be different on a long player record versus a 45, because you've got to get more tracks onto a 12-inch record, you could flick it over. So if you were playing long player or an LP, you flicked it over, or 45, or flick it over for a single. So coming back to the type of cartridge, so you can see the top left hand corner I show the stylus, and then you have a fixed magnet, okay? And this is the thing about the moving magnet part, right? So you have this fulcrum, and then as the stylus travels along the groove, of course it will be moving up and down, and then what you have are these fixed coils. So because the magnet is fixed to the stylus, as it raises and lowers and moves, that mechanical movement then is then converted to an electrical signal, and then that electrical signal then represents of course the audio which is contained within the vinyl track, and then that signal then is then fed directly to a phono equalizer stroke preamplifier, and the moving magnet is the most common. But you also have the moving coil. So thinking logically, as you see here next to it, the difference now is that it is a coil that is fixed directly then to the cantilever for the stylus, and now the magnets are in a fixed position rather than previously the coil. So what then happens as the stylus then moves up and down, it is the coil which is then moving with the fixed magnet, and again it will produce a flux or an electrical current which will then start to flow. Now audio file people often will look directly for a moving coil type cartridge, and the reason for that is you can see here that the moving coil, you know, it provides a wider frequency range, all right, and the reason for that is due to the lower effective mass of the stylus. So many audiophiles will reach out and say, okay, I'm looking for a moving coil type cartridge. And remember, you can interchange these on modern record players, you know, or you know, you make the decision. You can, you know, can retrofit if you want, you know, different types of cartridges then. And then in terms of signal level, remember it's very, very low. So it's 3.33 millivolts, and the input impedance is about 47 k ohms. And then for the moving coil type, you're looking at a 305 microvolts, so very, very low, and then 100 ohms as well. Now, what I also spoke about as well was this mechanical noise, and because the stylus is moving up and down, it will pick up any kind of vibration. So when I think about a motor which is rotating and then the platen which is rotating, there will be mechanical noise. So on earlier amplifiers, you had normally a selection which was like a subsonic, and you then pressed it, and then what the circuit is doing then is it is looking specifically at the frequency which will be attributed to the rotation of the motor and the platen, and it will look then to filter it out. On higher end Phono Pre-Amplifiers, which are separate, you may also see this switch in there, but you know, some of them I've seen, but I have seen some, you know, where you just don't have anything like that fitted at all. Now, when we think about the production of the master disc, in the early days, really there was no sort of standard with regard to the frequency range and how the audio was recorded. So there were many manufacturers which were producing vinyl records, and as I said, there was no real sort of single standard. But in 1955, the Recording Industry Association of America created the equalization curve that you're seeing here. So you may well see in some technical documents referring to the IAA, as we can see. And what the idea here of the equalization curve, it just allows for longer recording times due to the width of each groove being decreased. So when I think about the long players, you've got to get a lot of audio on a 12-inch vinyl disc, you know, a lot. So what you can do here is by implementing this equalization curve, you're able then to get up to 30 minutes of recording audio onto a single side of the long player. And how this is achieved is during the cutting phase, you can see that the recording curve reduces the frequencies and reduces the lower frequencies and increases the higher frequencies. And then when we think about the phono equalizer, it's the inverse of that. So during playback, then instead of the reduction of the lower frequencies, it then increases them, and then instead of the increase of the higher frequencies, it then reduces them then. So this really is the equalization curve. When you think about Phono Pre-Amplifiers and also inbuilt Phono Pre-Amplifiers, this is what the manufacturers are adhering to. And when we think about the human hearing range, you can see here. So when you're born, it should be 20 Hertz up to 20 kilohertz, but as we age, that frequency range will be reduced. It's sort of interesting also as well that often, when I think about high-end turntables which cost thousands of pounds, dollars or euros, normally it's when you're older that maybe you've amassed some wealth where you can afford them, and yet at that point, your frequency range for hearing has been reduced. Naturally it's been reduced, and for anyone who's worked in maybe in a heavy industrialized environment where you have a lot of noise, then again that can also cause hearing reduction as well then. But sort of interesting, from that sort of take on things then. So this now is the standard, and as I said, historically, before 1954 and this equalization curve was put in place, really there was none. There was no standard at all, and many different types or techniques were implemented then to achieve what is now done with this standard here. Now the next thing that I want to sort of look at and share with you are the sort of circuits that you see within the separate Phono Pre-Amplifiers. So I'm going to use a very good example, and this is a Cambridge Audio, and this is the 540/640p Phono Pre-Amplifier then. And what's nice is that when you look at the circuit schematic here, they have three of the things which I mentioned earlier. So if you look towards the left hand side, you can see that it's showing you the moving magnet input, and you can see the circuitry there. And then they also are showing you the left and then the right channel. And then what you also see is the subfilter. So this is this subsonic filter, so they're getting rid of any vibration stroke noise which could come from the motor or the turntable. And remember, when the platen then sort of is fixed in place, it may be driven from a belt or from the idler wheel. So then you have bearings within the motor which can generate mechanical noise, but also as well the platen would also then go onto some form of bearing, and again you can have this mechanical noise from there then. And then, as we mentioned a moment ago, you can see the equalization circuitry there. So again, it's to the standard, and then the left and then the right channel output then. So really a good example. Now, just to see, sort of give you a little bit more insight as to what we're seeing here, where you have like the moving magnet input coming into it, what they're doing here, because the impedance is fairly low, I think it's 47 kiloohms, sorry, fairly high, 47 kiloohms, you have this moving magnet, as it's saying here, and we have these long tail pair. And this is very common, because when we think about the signal level which is coming in from the turntable, it's 3 millivolts or approximately, so it's very low. So what you need to do here first of all is you need to amplify that up, because when we think about a line input for an amplifier, on some of the earlier ones it's probably about 150 millivolts, and then on more sort of later amplifiers probably up to about 230 up to 250 millivolts. So you've got to take that very low level signal which is coming directly from the stylus, amplify that up to a line level, and then at the same time you need to apply the equalization curve, and prior to that you need to remove any noise, because that's the last thing you want to sort of amplify. But this is more of a modern circuit. So you have discrete transistors, which are the long tail pair, and then after that it then goes into these operational amplifiers, and you can see all the different filter networks. So there are resistors and then capacitors to provide the necessary filtering, and then ultimately on the output stage you can see again it has been amplified up, and then you also have the direct connections to the RCA sockets at the rear. And then the next example, this is where you have an inbuilt circuit. So if we think about early amplifiers, you always had a phono input connection. When CDs were launched, you saw a movement away from that. So people were moving away from vinyl records, and so all the inputs were high level or line inputs, and you can still use them, but as we saw a moment ago, that's when you have a separate Phono Pre-Amplifier. When you have an integral, then it's built onto the boards. Early amplifiers, as I said, always had that, but now with more modern amplifiers it's gone full circle. So it's very, very common to have a moving magnet, equalization and pre-amplifier circuit on the main amplifier board. And I'm showing an example here, which is a Marantz PM 4200, and it doesn't support moving coil, but what it does support is a moving magnet. Now what they've done, again very, very common, is that they use these dual operational amplifiers. So this here is IC11, which is in the center part of the circuit diagram, and then what you have is the connection then coming directly in. And in terms of power, you know, this is the same also for the standalone Phono equalizer preamp. It's normally plus or minus 15 volts. It could be 18 volts, but normally it's plus or minus 15 volts. So here what we have is exactly that. So you can see here that the power to the operational amplifier is minus 15 volts and plus 15 volts, because of course we're amplifying both a positive and a negative audio signal. And you can also see all the different filter networks around there. So what this circuit is doing is the same as the one previously. So it has to do the equalization, it also has to do the pre-amplification to get it up to that line level before it's then fed maybe into the tone circuits of the amplifier, or if you choose to bypass them via the volume control, it will then feed into the voltage amplifier stage of the main should we say main amplifier board, or the voltage amplifier stage of the power amplifier. And then if we sort of move on and we sort of talk to you about typical types of faults that you can see, the first thing that you need to look at is the physical connection of either a turntable to your Phono Pre-Amplifier or from your turntable to your amp. Okay, so on all turntables what you'll find is that there is a ground wire, or sometimes it's referred to then as the screen connection. And remember, modern day turntables can also have an inbuilt Phono Pre-Amplifier, and you have a slide switch where you can select between the two. If it doesn't, then it's going to be moving coil or moving magnet, and you have this ground wire. And on all amplifiers which support such a connection, you'll also find it will be marked Phono ground, and I'm showing this in the video. So top left we show the example, and this is from an installation manual, and it's showing you the rear of an amplifier with a Phono input socket, and you can see the ground connection from the turntable to the amp. And then on to the right of that, this is a Technics amplifier, and you can see the ground connection there. And this is very, very important, right? Because if you don't, then you can get electrical noise, or what we term as like as a power hum. So that ground connection is very, very important, and it must be connected then. And then what I'm also showing in the video are typical circuits, and again these circuits have been taken from, I believe, a Technics amplifier. What you can see are the moving magnet type circuit boards. So the first one that I'm showing are two individual boards. So this is where you have a moving coil and moving magnet type, and they then plug in. And then the other one that I'm showing here is a Cambridge audio amplifier, and it could be an A5 or an A500 or A300, and you have a dedicated board which you can install, and you can see there's quite a lot of circuitry on there, and this could be retrofitted, you know, at a later date, or could be integral. Now on the lower part of the video screen, what you can see are RCA ground caps, and these are very common. When we think about older amplifiers or we think about newer amplifiers, it's very, very common to have these RCA grounding caps, and you just put them onto the phono socket inputs and it will effectively ground the input then. Because the signal level is very, very low, a few millivolts, it acts a little bit like an aerial. So if you touch like the positive or the negative, sorry, the positive of the right or the left channels, maybe you use, say, a metal screwdriver, you would then pick up the power hum maybe within your home. So it's like a 100 Hz power hum or 50 Hz power hum, and then you could then just amplify it up. And it was very common, you know, audio engineers or repair engineers, you know, as we're working on equipment, if we just want to just do a quick test, you know, you've only got to just put your finger onto the signal part of the connection, and the amplifier will amplify that 50 Hz power hum then. So you can fit these grounding caps. Now, if you're in the process of repairing amplifiers, they're very useful, because sometimes you can get like a noise or a power hum, and trying to track it down, so, well, you know, is that coming from external or internal? If you fit the RCA grounding caps just to test, of course, by grounding the input, you shouldn't have maybe a power hum. If you pop them on, you still have that, then you know it's within the amplifier. It could be due to, you know, power supply or something else. But you know, really, really useful then to have. And then what I also show here are some examples. So I'm showing you some examples here of and this is a NAD pre-amplifier, and you can see there's just a couple of op amps, and there's a few resistors and capacitors, but really not a lot in there. Yet to the right of that, you can see then that we have a Cambridge Audio one, and then this one, you know, is supporting, you know, a moving coil. It also supports a moving magnet. It has the subsonic filter as well for the rumble noise elimination, and there is a lot in that little device, an awful lot. And again, depends on how much you pay for these, depending on, you know, in terms of design and then technology. And you can also get now, you know, probably retailing, you know, for a few dollars really, these sort of entry-level pre-amplifiers or stroke equalizers, and they're not too bad. You know, if you're sort of entering into it, you're not looking for audiophile quality, you know, they will serve the purpose. Now, in terms of typical types of faults, and really we're sort of coming to the end of the video here, you have to remember what signal level you're dealing with, and because it is so low, the elimination of any type of noise is absolutely critical, because once it's into the amplifier circuit, then ultimately you're going to hear that through your headphones or through your speakers. So you need to minimize that as much as you can. So yes, as I said earlier, it's very, very important to ensure that your signal connections to your amplifier and your ground wire are correct, all right, because you don't want any ground hum coming from, you know, misconnection or just leaving the ground connection off. Now, when we think about the circuit inside of an amplifier and even these separate preamplifiers, remember that the power supply has to be clean and it has to be noise free as much as it can be. And I did a previous tutorial where I was talking about power supplies. So here we show some examples where you can see the electrolytic capacitors being used in these different types of amplifiers. Now, the electrolytic capacitors will charge to provide capacity, so it's able to then, you know, it's amplifying the sufficient current or voltage available then to provide that required power level. But at the same time, electrolytic capacitors are very, very good at removing low frequency noise. So most things are powered from mains operation, so after rectification it's going to be in the UK at 100 Hz, in the US they have 60 Hz, so it'll be 120. With the filter capacitors, they will get rid of that low frequency noise, but you will also have smaller value capacitors, for example 100 nanofarad, and they are more on the higher end, so they're looking at the higher frequency to eliminate noise in that case. So it really comes down to making sure that the power supply design is good, and then also as well ensuring that you have both the correct low frequency and higher frequency filter capacitors in there, and it's not uncommon to have multiples of these. So when the supply voltage comes in, and remember you've got this plus or minus 15 volts that you've got to get to power these circuits, you'll do the high and low frequency filtering, and then it then goes into some form of voltage regulation because you need to keep the voltage constant. And then after voltage regulation, it's not again uncommon to see additional filtering. So you could have yet again some high frequency 100 nanofarad capacitors connected on the output and maybe the voltage regulator circuit to eliminate noise. And that's very, very important. You'll also see when engineers design the circuit board layout, they pay a lot of detailed attention onto where these copper tracks go and where the ground connections are, because what they want to do is they want to minimize the signal paths as much as they can, and really that helps then to reduce overall noise being induced into these preamplifiers stroke main amplifiers as well. Now I'm showing here as well, and for anyone who's a regular sort of listener to the channel, I often talk about this brown glue, and this is again very common. So if you are working on older type amplifiers where they were using glue to provide some form of mechanical strength to capacitors, if you see this glue and it's dried out, it's a very, very dark brown colour, it has definitely become conductive and also corrosive. So these Phono Pre-Amplifiers here on the bottom right hand side, this is a Cambridge Audio 1. And this is probably the most common fault you will ever see on that type of Phono Pre-Amplifier. When you turn it to the side, you can see the brown glue, and it's started then to corrode through some of the resistors in the power supply. It's also coating some of the rectification diodes, so you have to remove it, and it is a common cause of failure for these types of Phono Pre-Amplifiers as well. In severe cases, you may even find that the brown glue has started then to corrode or burn through the copper track. So again, just be aware of that. And then electrolytic capacitors can then fail, so we hear this power hum that you'll hear, and then also the higher frequency capacitors. Now when we think about electronic components can go electrically noisy, and you think, well, you know, what do you mean when you say electrically noisy? So if you think about a transistor or an integrated circuit, which is a silicon device, or even a diode, the internal junctions inside then can start to break down. So instead of it being barriered as it should for the correct current flow, what will happen is you start to get it's like it breaks through. And these components also can go thermal sensitive. So if you experience this, you can almost like hear like a crackling sound. It's literally like a crackling or rumbling sound, and it may just be on one channel of the preamplifier, but it could be on both. And then when you look at it, you can't see anything physical, but it's a process of elimination. And now remember, that kind of crackling sound and noise can also come from other components as well. So when I think about ceramic disc filter capacitors used for high frequency filtering, the dielectric inside again can start to break down, so you can hear this noise. Now if you use maybe an oscilloscope and you're trying to fault find, you know, you may see something, but for myself I always use an audio signal tracer, and that's very effective because with that probe, and it has a capacitor inside which blocks any DC, and then it then goes into a small little operational amplifier, and I can hear the audio, and I can literally put the probe and I can trace through the noise. So I trace through maybe to one of the inputs of the op amp, and I can't hear any noise, and then I then look at the schematic and then refer to the output pin of the op amp, and then if I hear electrical noise, then it could be from the op amp, or it could be from a ladder part of the circuit. So then it's a very, very easy case then to just remove the op amp I can then again go to the circuit point on the output, and if the electrical noise is gone, that really tells me actually that the op amp is the cause. And you can do that also with the transistors, the same thing. Now if it's thermally sensitive, you have something called component freezer spray, and any workshop will have this available, and I've seen many amplifiers and pre-amplifiers where components go thermally sensitive. So the way in which you do that is the amplifier is working, and then after maybe a few minutes you start to hear this crackling or noise starts to come through, and you're looking around, you can't see anything, and then you use the freezer spray, and don't just sort of take the spray straw off it and just spray it across the board. You want to localize it down to a specific component, so leave the spray straw in place, and literally as you press the top, just drop some of the liquid onto the component that you're testing, and then it just ices over, and then when you're listening you hear the noise disappears, and you can then reheat the component. So as the ice then thaws out, or maybe you just hover across like with your soldering iron just to you're not making contact with it, you're just producing more ambient heat. Within a few seconds you then start to hear the noise then come through again, and you can do that with the capacitors. Alright, so in terms of electrical noise, just to sort of finish off on this, most important, make sure that your connections are good and that your ground connection is made. Your signal wires are good, you don't have a broken negative or positive signal lead. In terms of fault finding internally, remember that these phono sockets that you see can also break away from the circuit board. So you may have the negative part of the phono input socket is broken away because they have mechanical stress when they're fitted, so double check that, and that's why I'm showing these boards have been removed from the amp. Or you may have these plug-in type circuit boards where you can isolate it to the board and then fault find that. And then, as I said, if you want to sort of try a process of elimination, is it coming externally or is it internally, you can use the RCA grounding caps. And remember, the RCA grounding caps can be left in place. Many people don't have a record player or turntable, but they just want to ground the phono stage just to eliminate noise. More modern amplifiers, it has electronic switching. On the older amplifiers it was a mechanical switch, so the signal was still coming in. If you grounded it out, it just helped them with overall noise reduction. And then for your power supplies, if you look at electrolytic capacity and you have power hump coming into these preamps, you may well see that the electrolytic is slightly raised, or maybe you can see some form of electrolyte is leaking out. But check that, make sure that it's not due to a power supply failure. And then the same also with the higher frequency filter capacitors. And then when I refer to the brown glue, very, very common. And then if it's none of those faults, you have this sort of crackling sound, then you're normally looking at a component which has gone noisy. And as we mentioned, it could be a transistor, it could be a capacitor, it could be a diode, it could be one of these integrated circuits. For the many years that I've been repairing equipment, I'd say for Phono Pre-Amplifiers, most common faults tends to be the ones where they have the dual op amps. That's my experience. I've probably fixed more Phono Preamps with that type of fault, where they just go electrically noisy. And even on the early Creek Audio Phono stages on those amps, the 4040 series, it was normally the op amp that tended to go noisy, and you can replace them, and even like now they are readily available, or some people will actually install a more improved modern up-to-date operational amplifier. Pinouts tend to be the same, you don't need to modify anything. And then also capacitors or transistors. These Phono Pre-Amplifier stages, you don't really sort of come across them with field effect transistors in there, but be aware, like a bipolar transistor, you could also get a field effect transistor can also go noisy as well then. So that sort of brings us to the end of this tutorial. So for myself, always a pleasure to share sort of insight and provide insight. I'll probably have a think to do something similar on a different topic. I've done a number of these over the last few months, and they always tend to get sort of good feedback and high viewing figures. So hopefully today you've learnt an awful lot. And then, as I say, I'll put my creative head on, and I'll see what other subjects we can kind of cover. All right. So I really appreciate it, as always. I always say that to you all. I do appreciate you stopping by, and I thank you very much for listening. Until the next time. Cheers. Bye bye.